Hi class, welcome back to KQ's channel. I'm Madam Chan here from College Abdillah. So today we are going to continue to look at graph of motion. That's the second part, which is speed time graph. Okay, in this speed time graph, you are going to see the vertical axis over here. It represents the speed of a motion. And then for the horizontal axis, it represents the time taken. Whereas the gradient of the graph over here, it represents the change of rate of speed with respect to time. So this part is actually the acceleration. Okay. A speed time graph can be drawn if the following information about the motion is obtained. This is just like the first one that you have learned, the distance time graph, whereby you can draw the graph as long as you have the speed timetable. And then the second part is the equation that represents the relationship between speed and time. Okay, we are going to look into it. So here's the example one. The table below shows the change of speed of Inche Azizul's car for a period of 5 seconds. So you can see the time here for a period of 5 seconds. And then they ask you to draw a speed time graph based on the given table. So the speed given here is in meter per second. The given value is 0, 10 up to 50. So we can see here for the time, they are all uniform, including the speed, right? Therefore, just like the first distance time graph that you have learned, what you need to do when you are going to draw, when you are asked to draw a speed time graph is, you need to plan a proper scale. Okay, choose appropriate scale. So over here, we are just going to choose 0, 1, 2, 3, 4, 5. And then for the speed is still using the same, which is 0, 10, 20, and so on. After that, you plot the point and then you join the plotted point using ruler. So we can see the graph is like this. Okay, this is to represent the time in seconds. And then this part is to represent the speed in meter per second. So you just plot everything and draw, join up using ruler. Now we look at the next example here. The rate of change of speed of an aeroplane that is landing is given by the equation v equal to 800 minus 1600 t, where v is the speed in kilometer per hour and t is the time in hours. Draw a speed time graph to represent the landing of the aeroplane for the period of in between 0 to 0.5. Okay. Now, you look at the question here. A, construct a speed timetable as shown below using the equation v equal to 800 minus 1600 t. So, we are going to construct a speed timetable, which is the table of value, by using the range given here, which is 0 to 0.5. So, when the period, the t is 0, you are going to substitute the t is 0 over here, which means the v will be 800 minus 1006 times 0 is 0, right? So it's still 800. And then when the t is 0.5, which is a half, you multiply by 1600, it will be 800, right? So 800 minus 800 will be 0. Then you can have a speed timetable like this, whereby t is 0, speed is 800. If t is 0.5, speed is 0. Then from here, you draw the speed time graph. So we have the value given already. This will be 0 and 800. You just draw the vertical and horizontal axis to represent the speed and also the time. And then you plot 0 and 800 over here. And then 0.5 with 0 here. And then you join up using ruler. So this is the graph that is drawn. Okay, now we look at the next one, which is the relationship between area under a speed time graph and the distance traveled. Okay, so you can see the diagram one here. This is the distance time graph. Okay, so the gradient over here, it represents the speed, right? As previously you have learned in distance time graph. So it is different for speed time graph, whereby the area that you can see, it represents distance. So this is the speed time graph. When you convert everything over here, v to represent the speed, t to represent the time. So we are going to see the area under a speed time graph. Okay, to find out the relationship between area under a speed time graph and the distance traveled. So for example, you look at the statement here. Injed Faisal drives a distance of 200 km in 4 hours. So from the question here, we know that the speed is distance divided by time. 200 divided by 4, it is 50 km per hour. Then to draw a speed time graph, you need a speed, right? The speed is 50 km per hour, and then the time is 4 hours. So it is a straight line like this. Okay, then you can see the area here under the graph. How to get the area? To get the area, it is 4 times 50 km per hour, right? So we will have 200 km, whereby this one represent the distance traveled. Okay, so distance traveled, D is equal to S times T, speed times time. So 50 times 4, it is equal to 200. Therefore, from here, we know that the area under a speed time graph is the same as the distance traveled for the same time interval, this part. Okay, whenever they ask you what is the distance for a speed time graph, to find the distance, you just find the area under the graph. So for a speed time graph, area under the graph is equal to the distance traveled. Now we look at example 3 here. Calculate the distance traveled in each motion based on the following speed time graph. So to calculate the distance for the diagram A here, it is represented by the area under the graph, right? This is the area. First, you have to identify the shape. What is the shape here? It is a trapezium, right? So do you still remember what is the formula of a trapezium? It is 1/2 times the height multiplied by A plus B, right? So you have to identify where is the parallel line here. The parallel line is this 2, and then the height is right here, which is 4/5. The length here is a 10, and then this part here is a 5. Okay, so the answer will be 1/2 times 5 plus 10 times 4/5. Then you simplify it. For example here, 2 times 1, 2, 2 times 2, 4. So 10 plus 5 is 15 here. You can simplify with the denominator down here, 515, 5, 3, 15. So 3 times 2, you get a 6 kilometer. Okay, why? Because the hour here, per hour, you cancel with hour. The remaining unit is kilometer. Okay, now we look at diagram B here, another speed time graph. So to get the distance here, you can see two shapes, which is a rectangle and a triangle. It's up to you whether you want to find the area of a triangle plus a rectangle, or you can find the whole area here, which is represented by the trapezium. Okay, so where is the parallel line? Can you identify? This is the parallel line. Okay, the length for this here is 80, and then the other side is a 40. Okay, and the height here is a 6. Okay, now you have to make sure of one thing, because the speed given here, the unit is kilometer per hour, but the time here given is in minute. So later on, you will have to change the minute into hour. How to change minute into hour? Divide by 60. Okay, so to get the distance for this one, it is 1/2 times 6. So the 6 over here, because it is in minute, you have to change it, become 6/60 hour. And then multiply by 80 plus 40. So you can see it's like this. Okay, here we change it into 6/60. So simplify everything, you will have 6 kilometer for the distance traveled. Okay. Now look at example 4 here. The speed time graph shows the speed of Mrs. Liu's car for a period of 36 minutes. So you can see 36 minutes here. Calculate the total distance in kilometer traveled by Mrs. Liu's car for the period of 36 minutes. So meaning that you have to calculate the whole area under the graph, this part down here. So before you proceed, you have to identify the shape here. The shape here, the first one is a triangle. The second one here is a trapezium. And the third one here is also a trapezium. And then you got to bear in mind, this is kilometer per hour. This is the time in minutes. So later on, you have to divide the time into hour, which is divide by 60. Okay, so find out the value one by one. This is a 10 here. This 20 minus 10 is another 10. 36 minus 20 is a 16. The height here, this part, is 72. This part is 40. This length is another 72. And then that's all right. So it will be Sorry, this is what I've told you just now. 1 minute equal to 1/60 hour. You have to remember this. So it will be 1/2 times 10/60 times 72. So this is represented by the first part here, number 1. And then number 2 is a trapezium, right? So it is 1/2 times 10/60 times 40 plus 72. And then the last part is 1/2 times 16, because it is 16 minutes here, times 40 plus 72. Okay, so you just add up everything and you will have 30.27 kilometer. Okay, for B, they ask you to find the average speed in kilometer per hour for Mrs. Liu's car for the period of 36 minutes, meaning that for the whole graph over here. So you got to remember what is the formula of an average speed. The formula is total distance divided by total time. So you already have the total distance, which is 30.27 here, right? The total time is 36 minutes. Therefore, you have to change this into hour, because the required average speed is also in hour. Okay, therefore it will be 30.27 divided by 36 divided by 60. Then you will have 50.45 kilometer per hour. Okay, now we look at the interpretation of the speed time graph. So this is a speed time graph. On the left, the one that we have, we can see the one that going up is acceleration, and then the one that is straight line is a uniform speed, and followed by deceleration down here. Okay, so for PQ, the speed of object increases from u meter per second to v meter per second. Here we can see u to v. And then the gradient of the graph is positive because it's going up. Hence, the rate of change of the speed is positive. So to find out the acceleration, remember this part is acceleration now when it is a speed time graph. So it is the change of speed, which is the vertical distance over here, over the changes in time, the horizontal distance. And then the area for trapezium A, the pink color part here, is the area under the graph. Okay, it represents the distance in the period of t second. Okay, now we look at part B and part C here. The next one is part B. From Q to R, there's no change of speed because the gradient is 0, also meaning that it is a uniform speed. And then the area of the rectangle B over here, this one represents the distance traveled in the period of T2 minus T1 second. Okay, then we look at C here, the triangle. When it is going down, it is deceleration. So the gradient here is negative, meaning that the change of speed is also negative. Okay, so when it is going down, it's deceleration. To find out how much is the deceleration, it is the same as acceleration. It is the change of speed or change in time. Okay, and then there is no change in the direction. That is, the motion of the object remain in the same direction. Okay, and then the area here, it represents the distance traveled from T3 minus T2 second. Okay, you understand everything? If you don't understand, you can refer back to your textbook. It's in your textbook. Okay, now we look at example 5 here. The example, Mr. Daniel Wong drives his car to a convenience store to buy newspaper. The speed time graph shows the motion of the car from his house to the road junction before reaching his destination. Okay, so describe the motion of Mr. Daniel Wong's car for the first 10 seconds. First 10 seconds is over here. When they ask you to describe the motion, you have to describe the speed or the acceleration here, the motion. Okay, so to find out this part here, it is the rate of change, right? Rate of change is the change of speed, which is 25 minus 0 over the changes in the time, which is 10 minus 0. Okay, so you will have 2.5 meter per second because this one represents acceleration. Okay, so -1 minus 1 becomes -2 here. Therefore, the car accelerates at a rate of 2.5 meter per second for the first 10 seconds here. Okay, that is the description. And then for B, what happened to the motion of Mr. Daniel Wong's car from 10 second to 20th second? From 10 to 20, it is a straight line, right? No gradient, meaning that it moved at uniform speed. Okay, so the answer, Mr. Daniel Wong's car moved at a uniform speed of 25 meters per second from the 10th second to the 20th second. And then for C, calculate the rate of change of speed in meter per second for the last 5 seconds. So this part is the last 5 seconds, meaning that you have to find the change of speed, that is the difference in the vertical axis, 25 minus 0 over 35 minus 20, because this part is the last part, right? The final speed is 0 minus 25 over 35 minus 20. Okay, so 0 minus 25 over 35 minus 20, the answer is negative 5 over 3 meter per second per second. So you can see here when it is negative, meaning that this part here is a deceleration. So you can write the answer as acceleration equal to negative 5 over 3, or deceleration is positive 5 over 3. Okay. Not one more thing. We can find, because they mentioned about 5 seconds, the last 5 seconds, right? The last 5 seconds is actually here, which is from 30 to 35. So directly we are just going to use the motion over here, because the motion on this point is always the same. Therefore, we will have 0 minus 25 over 35 minus 20. Now we look at D here. Calculate the distance in meter traveled during deceleration and describe the motion of the car for the period. So it is this part, right, the deceleration. So to find out the distance, it is the triangle. The formula for triangle is 1 over 2 times. Here the base is 15 times 25. So you will have 1 over 2 times 15 times 25. It is 187.5. Okay. One more thing, they ask you to describe. So when you describe, you have to describe the distance, describe the time, describe the speed. So the car travels for, the distance is 187.5 meters in 15 seconds with the speed is in deceleration of 5 over 3 meters per second per second. Okay, now we look at example 6. The speed time graph shows the motion of a car for a period of 14 seconds. Calculate the average speed in meter per second for the first 6 seconds. So the first 6 seconds is over here. When they ask you to calculate the average speed is equal to total distance over time, right? Over total time. So we have to find the total distance over here. Then if you look at the shape, this part for the first one is a trapezium, and then the second one here is a rectangle. So you have to find the area for the shape here. So this part is 4, this is a 5, and then this line is a 10. The one at the back also 10. Therefore, the total distance is equal to 1 over 2 times 4 times 5 plus 10, and then you plus with, this part is a 2 times 10. So you will have like this, 6 minus 4 is a 2, 2 times 10. So you will have 50 meter. So to find the average speed is the total distance, which is 50 meter over 6 seconds. Therefore, the answer is 25 over 3 meter per second. Just follow the unit meter per second. Okay, now we look at B. Find the value of t if the distance traveled by the car for the first 4 seconds is half the distance traveled at a uniform speed. So the value of t is right here. If the distance traveled for the first 4 seconds, this is the first 4 seconds, okay, and then it is equal to the half of the distance traveled at the uniform speed. So where is the uniform speed? This part is the uniform speed, right? Therefore, you have to make equation over here, which is the distance traveled, 1 over 2 times 4 times 5 plus 10 is equal to half t minus 4 times 10. Okay, this part here is t minus 4. Therefore, you simplify everything and you will get a t is equal to 10. Okay, now you look at C. Find the value of v if the acceleration of the last 2 seconds is 3.5 meter per second per second. So v is right here. If the last 2 seconds, where is the last 2 seconds? These two, right, which is 13, 14 is equal to 3.5 seconds. So you have to find the acceleration over here. But if you look at the acceleration, if you want to find the acceleration, it is the rate of change, right? Changes in y over changes is in x. But we don't have any value in front here. So what we do is we are going to take the whole line, because no matter how, the motion is still the same. Therefore, the point here is represented by v. This part here is a 10, okay, over 14 minus the t just now that we get is a 10. Okay, so we will have v minus 10 over 14 minus 10 is equal to the acceleration given, which is 3.5. So over here, you are just going to solve it. This part is equal to 3.5 times 4, you will get a 14. So v is 14 plus 10, you get 24. Okay. Then you look at example 7 here. The speed time graph shows the motion of two vehicles. Graph OAB represents the motion of Inject Zabadi's car. So OAB is the red one here, the pink one, Inject Zabadi's car. And then graph CD represents the motion of a taxi by Mr. Law, the green one, Mr. Law. Okay, the difference between the distance traveled by the car and the taxi in the period of 24 seconds, okay, in the period of 24 seconds is 160 meter. They ask you to calculate the value of V. Okay, remember, the difference between the distance traveled by them is 160 meter. Therefore, to find out the distance, it is the area under the graph, right? You have to make comparison in between Inject Zabadi's distance and also Inject Mr. Low's distance. So for this one, the length is V minus 10 here, this part V minus 10. And then the parallel line here, this part will be 24 minus 8, it is 16. And then this part down here is 24. So you will have 1 over 2 times V minus 10 times 24 plus 16. And then when they told you the difference means you minus, right? Minus the distance by Mr. Law. So it will be 1 over 2 times 24 minus 8, this triangle here, the area of the triangle, 24 minus 8, and then multiply by the length over here is V. Okay, the difference is 160, so you just equate it into 160. And then simplify everything, you will have V is equal to 30. Okay, now we look at the last example here in your book. Is on page 204. You can refer to your textbook. The speed time graph shows the motion of a van for a period of t seconds. So this is the graph given. The rate of change of speed is meter per second for the first 3 seconds. You have to calculate the rate of change. Huh? So the rate of change for the first 3 seconds. The first 3 seconds is right here. You have to find the rate of change. So this point is 30, this point is 12. 30 minus 12 over 3 minus 0. Then you get the rate of change is 6 meter per second. Okay, and then if you look at V here, the distance in meter traveled for the first 10 seconds, you have to find the distance over here. It is a combination of a trapezium, okay, for number 1, and a rectangle for number 2. So the formula to get the area for a trapezium is 1 over 2 times 3 times 12 plus 30, and then you plus with 10 minus 3 is 7, multiply by 30. So you will have a total of distance traveled in 273 meter. Then the last one here, the value of t if the magnitude of the rate of change of speed after 10 seconds is the same as the magnitude of the rate of change of speed for the first 3 seconds. So here you have to find the value of t. Okay, if the magnitude of change of rate of the rate of change of speed after 10 seconds here is the same as the rate of change of speed for the first 3 seconds. Okay, so the rate of change of speed over here is 6 meter per second, right? Therefore, this part will also be the same. So what you do is you are just going to make equation whereby you are going to add a negative here because the rate of change of speed is in the same direction. Okay, for this part is in the same direction. So 0 minus 30, this is 0, minus this point is 30 over t minus 10, this part here is equal to 30 minus 12, the rate of change here, over 3 minus 0. Okay, so when you make equation, you will have a more simplified form like this. Just simplify everything. Negative times negative is positive, and then 3 times 1, 3, 3 times 6, 18. So 6 times t minus 10, or you can just exchange it. 30 over 6 is equal to t minus 10. So 6 times 1, 6, 6 times 5, 30. Therefore, t is equal to 10 plus 5 is equal to 15. Okay, so that's all for the chapter today. I hope you enjoyed the lesson, and if there is any mistake that I mentioned, hope you can forgive. Okay, I'll see you again in the next lesson, in the next chapter.